Hello everyone, welcome to Chapter 6 Benzene and its Derivative SK025 Chemistry. In this chapter, we are going to talk about 6.1 Introductions of Benzene and its Derivative. So by the end of the lessons, you need to be able to describe aromaticity, calculate structures, and resonance structures of benzene. So first of all, aromaticity over here refers to the stability of compounds that are aromatics. So the common aromatic compound you know is benzene, C6H6. So the criteria for a compound to be aromatic, there's 4 criteria altogether. So let's look at the criteria of aromaticity. So first of all, this compound must be a cyclic compound. Second, it must be planar structure. And number 3, it must be completely conjugated. The terms completely conjugated here refers to the carbon-carbon double bond must be alternative and refers to the following structures. 3 of these structures fulfill the first 3 requirements. They are all cyclic and planar, and all the double bonds are completely conjugated. That means double, single, double, single, double, single. And it applies also for the other 2 structures given. But there's the criteria number 4 here you must check. You must check accordingly to the structures. So criteria number 4, number of pi electrons must obey Hooke's rules. So this Hooke's rules has a formula for n plus 2, in which this n refers to an integer. It must be a whole number. Right, so how are we going to check the criteria number 4? Okay, how are we going to check the Hooke's rules? It refers to the tables given here. So the values of n, it must be an integer starting from 0, 1, 2, 3, 4, and etc. So it can be 5, 6, and so on. So the number of pi electrons giving you a formula for n plus 2. So 4 times 0 plus 2 give you 2 pi electron. 4 times 1 plus 2 give you 6 pi electron. 4 times 2, 8 equals to 8 plus 2 give you 10 pi electrons, 14 and 18 and etc. So that means following the numbers, the values of integers given here, the number of pi electrons can only be 2, 6, 10, 14, 18 and so on. Alright, so let's look at the first structures, benzene. So giving in the structures over here, we have benzene and it has a formula of C6H6. This is quite a common aromatic compound that we're going to use in this chapter. So how are we going to look at the pi electrons? Refers to this double bond, each of the double bonds containing 2 pi electrons. So one of this double bond, you have 2 pi electrons, 2 pi electrons, and 2 pi electrons. So in total, there is 6 pi electrons in the structures of benzene. Alright, and this number 6 pi electrons, you can look from the table here, in which the integer equals to 1. So yes, it fulfills the Hooke's rules. So for this benzene, it will be an aromatic compound, as it fulfills all of the 4 criteria: cyclic, planar, completely conjugated, and it obeys Hooke's rules, as you get 6 pi electron, which is in the table. So the next structure given over here is cyclobutadiene. Okay, diene because the presence of 2 double bonds. So this is also a cyclic structure, a planar structure, completely conjugated as it has alternate double bond. But let's look at the Hooke's rules. So in this cyclobutane, you have 2 pi electrons here. You have 2 pi electrons. So each double bond contains 2 pi electrons. So altogether, you have 4 pi electrons. So in the table, it doesn't have any number 4. It doesn't have the values of 4. So if you look at the Hooke's rules, so 4 pi electrons, if it's used, it applying the formula for n plus 2, it will give you the values of n equals to 1 over 2. So when n equals to half, it is not an integer. So therefore, for this cyclobutadiene, it is not an aromatic compound. Okay, acid doesn't obey criteria number 4. It doesn't obey the Harker's rules. All right, and then the next structure is 14 annulene. So looking at the structures, it is cyclic, it is planar, it is completely conjugated, and let's check the Harker's rule. So altogether, 1, 2, 3, 4, 5, 6, 7, you have 7 double bonds. So that means altogether, you have 14 pi electrons. So you can look at the table. There is presence of value 14 for the number of pi electrons. So that means if you apply Harker's rules, 14 equals to 4n plus 2. Okay, therefore the values of n equals to 3, which is an integer. All right, it's an integer. So we can say this 14 annulene, it is aromatic compound. So for the structures of benzene and annulene, they both completely obey the 4 criteria: cyclic, planar, complete conjugated, and obey Harker's rules. So next, let's look at catalytic structures. Catalytic structures, the names is after a scientist which discovered the structures of a benzene. So benzene, it has a formula C6H6. It has a higher ratios of carbons to hydrogen. So ratio is 1 to 1, in which the ratios of carbon is higher compared to hydrogens. If you refer back to alkane, alkene, they have the higher ratios of carbon. So please correct the terms high ratios in your notes. Or we can also say that it has a higher percentage of carbon overall. So for this, scientists suggested that there is a fast equilibrium between these two isomers given below. So if you look at this alternate double bond is changing the position. So both of these structures are in equilibrium. So either one of these structures, when you draw it, it still obeys the criteria for aromaticity. So for this benzene, it actually exists as a resonance hybrid between two of these catalytic structure, and the pi electrons are delocalized in the ring. So the arrows written over here when we show the delocalizations of the electrons. Delocalizations means the pi electrons are free to move within these 6 carbon atoms. So that means doesn't matter you put the double bonds over here or the double bonds over here, as long as they are completely conjugated. So all of these 3 resonance structures or resonance hybrid we can use to represent a structures of a benzene. So that's all for our introduction 6.1.